Here we are going to be talking about equivalent ratios. Now, if we want to compare to other ideas that we have covered, equivalent ratios are similar to equivalent fractions. So what we're going to do is we're going to go over the notes. I have them here, but I'm also going to do some drawing over here to help us with some of the understanding. So it says, Kim is planting a border in her garden in Trail, BC. She plants 5 yellow daisies for every 3 red petunias. The ratio of daisies to petunias is 5:3. So remember, daisies came first, so 5 comes first, petunias come second, 3 comes second. How many petunias would Kim plant for each number of daisies? So in each case, what is the ratio of daisies to petunias? So we're going to start with a picture drawing. So we can use colored tiles. Now, I don't have tiles, but I do have 2 different colored markers I'm going to use. And so we know that for every 5 daisies, she has 3 petunias. So I'm going to represent daisies as orange. And I'm going to represent my petunias with this green color. So if I have 10 daisies, I'm going to start by drawing this in the ratio. So I have 1, 2, 3, 4, 5 daisies and 3 petunias. Now I'm not at 10 daisies yet, so I'm going to keep drawing. 1, 2, 3, 4, 5, and 3 petunias. Now I have my goal of 10 daisies, so I'm going to stop. The question asks, what is the ratio of daisies to petunias? So in this case, I have 10 daisies to 6 petunias. Now, I can keep doing this, so I could add another row of 5 daisies to 3 petunias to get to 15, and another one again to get to 20. But you can see that if we had really large numbers, this is not a super convenient way to do it. We definitely could draw it out, but it might take us a long time. So what we can actually do is we can use a table and patterns is another way that we can help organize this. So just like in the notes, we had, I'm going to scroll that up a little bit. So we have our daisies and we have our petunias. And I'm actually just going to move that down a little bit to get a little bit more room. Now, we know that initially we have 5 daisies for every 3 petunias. Now, as we continue to grow, I know that if I have 10 daisies, I'm going to have 6 petunias. So I can look at this and say, what did I do here? And in both cases, I multiplied by 2. So if I then want to have 15 daisies, I need to take a look at what's going on to get from the 5 to the 15. And to do that, I'm multiplying by 3. So to figure out how many petunias I'm going to have, I need to multiply that one by 3 as well. And so 3 times 3 is 9 petunias. If I wanted to know for 20 daisies, I have to look and see what is that rule that I'm following. What did I do to go from 5 to 20? Well, I multiplied by 4, so I need to multiply this one by 4 as well. So 3 times 4 is 12. Now, I could be super silly about this, and I could say, well, you know what? I have a really big garden. I want to plant 60 daisies. What do I need to do, or how many petunias will I need? So I can if you know your number facts, 60 is 5 times 12. So here I multiplied by 12. So over here, I'm going to multiply by 12 again. And so 3 times 12 is 36. Now, when we start looking at a number like this, we can see why maybe it wouldn't be the most fun thing to have to draw pictures for everything. And in a lot of ways, these are exactly like equivalent fractions. We get them in the same way. So each of these can be written. So I can write it as 5 to 3, 10 to 6, 15 to 9, and 20 to 12. So those are all what we call equivalent ratios because they all represent the same general situation that's happening just in a larger scale.